Hello, class. This is a recorded lecture for section 8.2, which again deals with solving a system of linear equations. So what we did in section 8.1 is solve equations with two unknowns. So we had two equations, two unknowns, and then we went to three equations and three unknowns. And we had all the variables in there, and we walked through something called the elimination technique. We're going to do a very similar concept here in the next section, except we're going to have a different representation of the equations, more like a way a computer would end up getting programmed. And this is the idea of introducing of matrices. And so the idea of a matrix is that we are going to, let me pull up the slides here. What we're going to do is take a set of equations, or a system of equations, I guess a better way of putting it, and represented it in this matrix format. And when we do that, you'll see that the concepts of solution is exactly the same as what we did in the last section. But you could see that when you're programming things and you're entering numbers in a computer, you don't need X's, Y's, and Z's, etc., where the rows and the columns will indicate those aspects of it. So let's walk through some of the definitions with regards to this. So the first thing is that the rows go across. So that's the horizontal. And each row will be an equation. And then the columns are the vertical. And each column will either be the variable or the output, which will be after the equal sign of each equation. And so the number of rows and the number of columns is called the order of the matrix. And it's always rows first, columns second. And so again, this is called the order of the matrix. So for example, the matrix that I have up here has 2 rows, 3 columns. So the order of this matrix would be a 3 by 2. And so each entry of a matrix is very similar to a spreadsheet. So if you're familiar with spreadsheets, which if you're a math person, you should be eventually, you probably will have this nomenclature pretty much under control. So the idea is that each entry is indicated by A is a number, right? And then the first number would be the row number, and the second number would be the column number. So for example, row 1, column 1, let's say row 2, column 2, et cetera, et cetera. And so when we're taking these equations, what we're going to do is to show you how to take the equation and put it into the augmented matrix format. And so if you're programming the computer, this is basically how you enter the data into the computer to solve these types of equations. And so let's take these two as an example. So I'm going to pull up the whiteboard here and do these two up here. So that'd be minus 6 and 2x minus 3y equals minus 5. So what we're going to do is generate this idea of an augmented matrix. And the idea is that we'll have the rows as the equations. So if this is equation, not 2, top one should be equation 1, right? Top one's equation 1, bottom one's equation 2. So we're going to cross out the first equation, cross for the second equation. So going down the first column will be variable x, second column will be variable y, and then we put this line here. That's what we mean by augmented. And then this will be the answer. So this is, if you think about it, the line is the equal sign. So what we do is we put the coefficients in here. So this would be 3 minus 4 minus 6 I forgot my other bracket over here. And then this would be 2 minus 3 minus 5. X, second column y, third column is the answer column. You could think about this as the equal sign. I put it on pause so I could put up another set of equations. Here we have 3 equations and we have 3 unknowns, x, y, and z. So that's important to understand that, because when you set up the matrices, and again, if this is equation 1, equation 2, equation 3, we're going to have 3 rows. Row 1, row 2, row 3. So if we set this up, how many columns are we going to have? Well, we have 3 variables, then we have the equal sign. That's where the line goes for the augmented matrix. And then the answers. So I'll just label these X, Y, Z. And then here's our equal sign, right? And then this would be the answer. So first equation, we have 2, we have minus 1, we have 1, and then the answer is 0. So what about this? Well, here's, we'll definitely want to point this out, is we have an X, so that would be a 1 in front of it, right? But there's no Y. So what do you put there? You put 0, right? Because 0 times Y is 0. And we typically don't write 0, Y in the equation, right? So that would be a 1, and that'll be a 1, and then X is a 1, Y is a 2. We have no Z in the third equation, so Z would be 0, and this would be 8. So you'll see that there'll be some MyMathLab problems that have you practice taking an equation and putting it into what we call an augmented matrix. Okay, so let's go the other way, where what we have on the whiteboard now is an augmented matrix, and now let's write it with regards to these as equations. So a system of equations like we did in section 8.1. So again, what I like to do is I always like to label these until you get used to it. So this would be row 1, row 2. So there's 2 equations, right? And then this would be X, this would be Y, this would be equal, and then this would be the answer. And so when you generate these, you would get, first equation would be 5X plus 2Y equals 13. And the second one is minus 3X plus Y equals minus 10. So here's a 3 equation matrix here. This is a matrix that the order would be 3 and then 4 rows. So it'd be a 3 by 4 matrix. Let's label these again. I think it's helpful at the beginning to kind of see the pattern. So this would be equation 1 for row 1, equation 2 for row 2, and equation 3 for row 3. This is our equal sign here. And so now we have 3 variables, X, Y, and Z. And this would be the answer. So let's generate the 3 equations. So the first equation would be 3X minus Y minus Z equals 7. The next one would be 2X. And so this 0 would be 0 times Y. You don't usually write that. And so I won't. And then this would be 2Z equals 8. And the third one is 0x. You don't write 0x, so I won't. And this would be Y plus Z equals 0. So this was the first of the recorded lectures for section 8.2. And the next thing is we're going to introduce how to solve these equations in this matrix format. And again, we're going to be using the elimination technique that we introduced in the last section.